The nice thing about IndyCar is with the refueling and everything, there is quite a lot of option for split strategy. So it opens up a lot of potential to do something tricky if you're down the back of the field, or to get caught out and have a really bad rest of your day.
On this episode of Tuned In, we have Malcolm Finch, who is a data engineer for Team Penske in the IndyCar series based in the United States. For those who don't know, I'm Tim, and we've got Andre here from High Performance Academy. And today, the topic we're talking about is all really about IndyCar and the role of a data engineer in IndyCar. One of the things I'm always struck by whenever I talk to someone that's working in a technical capacity in both IndyCar or NASCAR for that matter is really, I'm just blown away by the amount of sophistication and attention to detail going into these series. And as we'll hear as we go through today's interview with Malcolm, there's doesn't seem to be any end to it. Every avenue you talk about, there's multiple guys working on, whether it's simulation or wind tunnels or testing or whatever.
It's interesting with IndyCar as well, because it is actually a fairly tightly controlled class in that you've got a controlled chassis, albeit you've got a choice. You've got a controlled engine. Again, there's a choice, but there's so much adjustability, and particularly in the aero aspects of these chassis, that's so critical. And particularly, of course, they run on road courses and ovals, and a massive difference between their setup for those two applications, no doubt.
Yeah, for sure. And it was funny, even when we were talking to Malcolm, these guys have been running this chassis, I don't know how long, pretty long time, whether it must be like 8 years or something now for this current IndyCar chassis. And we're talking to this guy at Team Penske. This is an incredibly well-established IndyCar team. I mean, that team even owns the Indy 500 now, I think, the IndyCar track. It's just talking to them about the different combinations of aero components that they're still learning about.
Yeah.
Suddenly they might find a new mechanical direction on the car, and that has a whole lot of flow-on effects as now that they're running in a different window, whether it's a ride height window or a rake window or whatever it is, and that has a whole lot of these flow-on effects as far as different components in the car. And, when you talk about the aerodynamics there, like, there's nothing, as you say, all of these parts, they can't make any of these themselves. These are all off the shelf. But when you add all of these different things together, you've still got, hundreds of thousands of different potential combinations of, settings you can have on the car at any one time.
Yeah, and I mean, I guess the trick there between having an understanding of the effect of those parts before you ever get to a race meeting, and then the testing that goes into the likes of something like the Indy 500, where they've got so much testing before the event, just getting that car into the window and being a few tenths of a mile an hour faster than the next guy is really going to make the difference.
Yeah, we're talking tiny margins. There's really there's no bad IndyCar teams out there.
Yeah,
they're all full of clever people with plenty of funding in most cases, and they're really squeezing everything out of these things. It's almost seems like a nightmare to try and stack up against those guys. It's pretty incredible.
Another aspect that was interesting about this particular interview and is dear to our hearts, and for those maybe from the Northern Hemisphere, maybe not quite so relatable, but local legend Scott McLaughlin, who was racing in the Australian Supercars Championship and won the championship last year. He's moved to IndyCar with Team Penske, and Malcolm's actually engineering Scott. So it was quite interesting, Tim, I thought, just hearing about how quickly Scott McLaughlin has adapted from his V8 taxi in Australia to a slightly more refined single-seater wings and slicks car.
Yeah, and about Scott's background as well, from what I understand, he'd never competed in a single-seater before he got to IndyCar. He did a couple of tests during his last Supercars season, but what an absolutely incredible transition. And to be able to go in and actually compete, he's been very competitive at some races. And yeah, Malcolm definitely had some interesting insight into, the goings on there and how they've tried to structure things for Scott to try and make it as successful as possible. It certainly seems, from my perspective, he's certainly delivering on that so far.
Yeah, absolutely. And I think that probably just speaks volumes about the raw talent that a high-quality driver like Scott offers. And I mean, for the weekend warriors out there who we might go out and do some sort of club-level competition or maybe do a track day once in a while, it's easy to sit back and watch these guys bang around in supercars or Indy or F1 and think, well, I could probably do that.
You can't.
The reality is just, yeah, you can't. You're absolutely right.
But the other thing to touch on there as well, maybe just to give a little bit of hope to some people out there, Scott, when he originally, the way he got his break into supercars originally was as an apprentice fabricator for Gary Rogers Motorsport.
Yeah.
And that's essentially the model they run there with the young drivers. If you want to be a young driver in that team, you got to work on the floor with the guys. That's where he came from. He was fighting to get into the second tier supercar series. He was there building suspension arms and uprights and all sorts of things, in his day job. And here he is, running for Penske and IndyCar now.
Look, while it's not essential, as a bit of an aside, I don't think to be a successful race driver, you need to be able to build a suspension arm or fit it to the car. But
it's not many of those.
I honestly don't think it ever hurts to have a bit more of a well-rounded understanding of the car mechanically as well and how it all works.
Absolutely.
We'll move on as well. One of the posts we put up recently on Instagram, which actually leads quite nicely into this because it's a technology that I know all of the IndyCar drivers lean on, particularly Scott coming into the series with no knowledge of the majority of these US tracks, is simulation or using a simulator. And I think this technology has evolved dramatically, particularly over the last 5 to 10 years. I mean, a lot of people think of simulators as a glorified game. And while, yes, that has been the case in the past, we have actual quality race simulation software now and quality simulator hardware as well with triple screens or virtual reality. And this actually has now become a viable technology for improving your race driving craft as well as learning new tracks. What do you think about that, Tim?
Yeah, absolutely. I mean, it's just become so accessible. There's multiple streams to that, whether it's about the quality of the hardware, like you talk about, having a steering wheel that can provide enough force with at the right frequency, at the right high frequencies to simulate what the feedback you need as a driver in the car. Obviously, you're never going to have a simulation. Is by definition a simulation. It's not reality, and people shouldn't be trying to necessarily completely emulate reality with it. That's not what it's about. It can be used in targeted ways to being an incredibly useful tool about whether it's about drilling into yourself certain technique changes, whether it's braking technique, the way you're looking at the corners, the way where your eyes are on the track, all of the stuff that any driving coach will go through with you. This is an opportunity to go through and test it with, even though you maybe in some high-end simulators there's a bit of budget involved.
Sure.
It's nothing like running around in a car of your own.
No, I mean, just from my own experience, I've spent a fair bit of time recently with some lockdowns on iRacing, and I genuinely believe that it's improving my ability in an actual race car. And as you mentioned, like some of the factors there, concentrating on your braking technique, trail braking, the way the car responds, even if you're not getting the feedback through the seat that you would in a real car, the way the car responds is accurate to real world. Likewise, you can concentrate on your vision, and I think that's such an overlooked aspect that's so critical to being successful on the racetrack, always looking one step ahead of where the car is, your next braking point, your next apex, the corner exit, and just keeping your eyes sort of up the track a little bit further. And that's just been so important. The other aspect, I think, as well, is just getting consistency over longer runs as well, given that here in New Zealand we're about to jump into our endurance series, which is an hour-long race. I mean, not long in the big scheme of things, but definitely a different level of concentration needed to compare to maybe a 6-lap sprint race. Now, on that note, for those who are maybe interested in learning a little bit more about race driving technique, we do have our race driving fundamentals course out. We've actually got a couple of modules in there that cover aspects that I just talked about, such as braking technique, trail braking, also the use of simulation and vision on track. And if you are interested in checking that course out, you can use the coupon code podcast75 that will give you $75 off the purchase of your first course from HPA, and you can find a link in the description that will take you to that course. All right, with our introduction out of the way, let's get into our interview with Malcolm.
Let's go. Okay, so today we've got Malcolm Finch, who is a data engineer for Team Penske in IndyCar. Welcome along, Malcolm. Thanks so much for being here.
Thanks for having me, guys.
So could you give us a little bit of background as to where you've come from, what you study to get where you are, and what your role is now?
So I've been racing basically my whole life, but the engineering side of it really started to come when I went to Auckland University. So from there, I was working with international motorsport, and that just kind of started the whole career process. And now from international motorsport in Auckland there, then I ended up over here in Penske, working on an IndyCar team as a data engineer.
That sounds like a pretty steep jump up the sort of pecking order. How did that sort of come about?
It definitely, it was a little bit of a surprise to me to get the phone call from Penske saying they'd like to have an interview with me and everything. But it going from endurance racing over in New Zealand, and then came over to the States and was living in Florida for a little bit, did some endurance racing with IMSA. And then the team I was working for unfortunately shut down. And so that I was left kind of out in the open searching for a gig. And then this Penske were looking to start a sports car program and to expand their IndyCar program. And so it was a little bit of right place, right time. But it's worked out really well.
Nice one.
So let's go back to the university side of things. So what were you actually studying there? What paves the pathway for you getting into this sort of career?
Well, I studied mechanical engineering, which is one of the most popular degrees with any sort of race car engineering. But on the side, I did a lot of racing, but I also did Formula SAE, which a combination of all three of those things is really what leads you to getting a good job. And it's what people really look for when you're looking to go overseas and go racing and be on these big race teams. Just having that not only theoretical experience, but also the hands-on mechanical experience and to do some trial and error. I mean, when you're racing yourself, when you're doing Formula SAE, you're always testing stuff. You're always experiencing things that go wrong. Sometimes they go really well, and the competition and everything. So,
and with could you give us a little bit of background on your role? We're obviously going to spend a fair bit of time digging into the details of what it means to be a data engineer in IndyCar today, but could you give us a sort of broad overview of what a data engineer does in a team?
Yeah, so a broader overview for an IndyCar team anyway is definitely pretty much anything electronic that's on the car you are responsible for, as well as some other aspects like simulation, strategy, various sensor calibrations, and it's a very broad role in terms of a data engineer. I kind of think of it as the glue that holds the team together, because you're interfacing with the mechanics, the race engineers, you're interfacing with the truck drivers, and kind of doing a little bit of everything that eventually is very crucial to the car running.
Yeah, absolutely. And maybe for depending on how familiar people are with IndyCar, could you give us a little bit of a brief intro to what IndyCar is, what sort of race formats you use, and a little bit about the car?
So IndyCar, obviously open wheel racing, wings and slicks. Every so often we break out the rain tires. There's a combination of ovals and road courses, and also mix in some street courses there. So it's a very diverse track layout. But we do 16 to 17 races a year. The biggest event obviously being the Indy 500. So that's the pinnacle of what we want to win, other than the championship itself.
How would you guys rate the importance of Indy versus the championship? If you could have one, which one would you have?
I would have the 500. That's my, and I think the consensus is pretty similar throughout the rest of the teams across the board.
That's the holy grail.
Yeah, that is the big one. And the championship does mean a lot too, but it's kind of the first 6-7 races of the year are all focused on winning the Indy 500.
Just talking about the cars, unlike Formula One, where the teams actually construct their own chassis, you're dealing with a controlled chassis. Is that correct?
Yeah, so it's a controlled chassis. A lot of the parts are spec parts. You're allowed to, obviously you have a lot of options, a lot of aero options, a lot of different suspension geometry options, but you still work within a certain window. Which is kind of good from an engineering perspective, because I mean, it's good and bad. Formula One's obviously great from a design perspective, but from a race engineer standpoint, coming into an IndyCar, you're trying to find the most minute differences in between all of the cars. So that side of it sparks a lot of interest in the engineering world.
Working with a team like Penske with multiple drivers, or actually let's take a step back there. Can you tell us about how many cars Penske are running and the drivers?
Yes. Yeah. So we run 4 cars currently. It's varied over the years between 2 to 4 cars. And then sometimes for the big races like the Indy 500, we'll run a 5th car just to have another horse in the race. But we basically have 2 chassis per driver, and we swap, and usually one's kind of dedicated to a road course setup, and then the other one's dedicated to an oval, and we just kind of swap between those as the season goes on.
Is it a situation where if you go and destroy a car on an oval, you can just straight up take the road course chassis and use it if you need to, or is it not that easy?
Yeah, that's exactly what we would do. It's simply changing the geometry and everything that bolts onto it. So the chassis themselves are the same, but we do different things to an oval car, like you would body fit them a little bit differently. And you like gel fit them just to make sure all the little aerodynamic parts are flowing properly, and you don't have anything that would be hindering you with the speed.
And who are your current drivers at Team Penske?
So right now we have our man Scott McLaughlin, of course. We also have Will Power, Joseph Newgarden, and Simon Pagenaud. Now I've been on Simon's car for the last 3 years. And then just this year when Scott came over, when we expanded to 4 cars, that's when I popped over and started being a data engineer on Scott's car.
Now, I want to dive into, for those who are watching and maybe aren't from New Zealand and Australia and don't follow supercars, Scott McLaughlin is a supercars champion, also a Kiwi, so we're backing him. I want to talk a little bit about some of those challenges Scott's had that you've helped him through, with maybe moving from racing a taxi, let's call it a taxi, supercar, sorry, into wings and slicks. But I want to just get back to where I wanted to sort of head with the fact you're running 4 cars. How important is that when you're running a control chassis, being able to, I assume, make small tweaks across the 4 different cars and try and find a direction over the course of a race weekend?
Yeah, I mean, it's massive having the extra car's worth of data. It's quite amazing how that adds to your effect. And also, if you're trying to test things like dampers, we go through a lot of damper changes, or any other aero tweaks. If you're trying to run a different roll center, or if you're trying to run a different wheelbase, we can throw that on one car and just get the feedback from that. Or you could try 3 different things. So running 4 cars is immense. Some of the other teams, many of them are 2-car teams, but some of them, like Andretti, are 7-car teams. They have 6 or 7 cars. So it kind of varies up and down the field. Not in IndyCar, there's no minimum or maximum. So you could run as many as you want. But yeah, 4 cars.
As many as the budget allows.
Yeah, precisely. Running 4 cars is it's kind of that good little place where you have not too much data, but just enough, but all your guys are really in tune with what's going on and you get solid feedback.
Sure. Yeah.
That's one question I had is, you mentioned how useful it is to be able to make use of all of those data sets. Do you find with 4Cars you do end up with too much, or do you feel like you get to a point where you can't exploit all of that stuff? Because I've been 4Car teams in the past, and it is a challenge to sort of be able to. I found it a challenge to exploit all of that stuff effectively. It's certainly once you're during the race weekend anyway. Till very well after the race weekend, you get home, you got time to go through it. But how do you find that?
Yes, sometimes it is overwhelming, but we do a really good job of reducing all of the data. So we do a lot of post-processing after the session, and we've automated a lot of it. So a lot of it happens so quickly that you get your results really fast. And that was key to the momentum of moving forward and continuing with that system. Because I agree, I think sometimes in a smaller 4Car team, you would definitely be overwhelmed if I was just trying to overlay just overlay drivers' data all the time. But yeah, sometimes it is overwhelming. At Indy, for instance, that's probably the most overwhelming because we have so much testing and so much data being produced where we do 4 or 5 days in a row and we'll be running 6 to 7 hours a day. So you're just constantly collecting data, and that's when it becomes a little bit troublesome because the amount that you have and the direction that you think you should go might not be correct.
You just mentioned post-processing. So is that some bespoke software that Penske's had written, or is the systems out there that everyone uses for that sort of task?
We do a little bit of both. We do have our own software system. We have a software engineering team, and they keep a lot of our data reductions and everything in-house. But we do use other programs. Excel is widely used for general analysis. We've been utilizing Power BI, running Python codes to reduce some of the aero data, for instance, and visualizing it in Power BI.
Could you, for someone that doesn't have a lot of experience with processing data like this, could you give a bit of a sort of a description of what aggregating that log data down into some metrics actually means, what the sort of general processes and how you guys use that?
Sure. So obviously we collect a lot of data from all of the sensors. After a run, we would download the data and we'd basically process it through our machine or through our tools, which adds our own in-house math channels and takes all of the sensor readings and then would come up with certain visualizations that we choose, whether it be an aero balance for something relatively not too complicated. If we're looking for a certain aero balance and then checking it, you can instantaneously check, on lap 2, 3, and 4, I was at that aero balance and then something's happened. Or we came in and we made a change and it shifted more than we thought it was going to on our aero map. And so we're able to go look at that later and instantly know that what we thought was going to be the aero balance is no longer the aero balance.
So it's really about sort of distilling all of those squiggly lines down into some useful points.
Yes. Yeah. Essentially, that's making it simpler to analyze and not getting overwhelmed and being able to move forward quicker.
Let's talk a little bit about the data system itself. Is that also a control part? What flexibility have you got there?
So yes, the data logging system's all controlled. However, the ECU is very controlled. That's all set up by Chevy. Or from our side at Chevy. We also have Hondas in the IndyCar field, and Honda do their own, but it's the same ECU.
Yep.
But as a data engineer, we don't touch the ECU. We only deal with just the data logging side. But flexibility-wise, we're allowed to add any math channel we want. So we're able to do control systems. We're one of the few teams that make our own steering wheels. And so we're able to set up our own buttons and have our own control systems within that. So that side of it's really cool. That was actually a really cool electronics project that we had very early on when I started here.
When you say control systems, can you sort of expand on that a little bit? What specifically you're talking about?
Yeah, there's a limited amount that we're able to do in terms of driver functionality. So if we run a weight jacker on ovals, which expands and collapses the right rear spring. And so for that control system, how the driver would control that system, what buttons he uses, different things like that. If we want to reset the power control module, we can do that. If the driver wants to change pages or control some element of the dash, we can set up a system for that. We do a lot of work with shift lights, shift light timing. That's a really big control system. Just getting all of that as kind of a closed loop system.
Sure. And is all of this this logic that you're discussing here, is this all coming from the logger itself?
Yeah. So the majority of it comes from the logger, based off whether it's based off the sensors you have on the car and when you're setting up math channels for that, or if you're just doing it simply off a control side and just wanting to have a math channel run in the background just so you can view it on telemetry.
Mm-hmm. Yeah. And you said you've got some flexibility there with the logger. You can go through and change logging rates and what you're logging and everything like that. You've got, essentially, that's open to you?
Yes. Yeah. So definitely logging rates are all open. We do a lot of telemetry. So we try and send as much as possible on telemetry, but sometimes you reach the bandwidth of that very quickly. And it depends on where you are too. But yeah, logging rates they're all open. And math channels are pretty much unlimited. So if you want to do different math channels, you can. Internal onboard math channels, that is.
How about the actual sensors? Are they a controlled sensor set?
There's a set amount that you're allowed to run for a race scenario, but for testing, it's basically open. You can pretty much run whatever you want. There's two types of tests. You're allowed to do a team test, or you can do a series test. So the series test you have to do under race rules. So you're only allowed to run simple sensor packages. But for a teams test, you can go do whatever you want. We can do big aero tap wings. We can do everything.
Every time I ask a question, you come back with about four more sort of things we really need to dive into, which is great. So just to come back with the logging setup itself, could you give us an idea of those base sensors that you can run on a race weekend? And then you've just mentioned pressure taps, but maybe some of the additional add-on sensors that you'd run when it's a free-for-all?
Yeah, of course. So some of the more crucial sensors that we run that are part of the base package are the ride height lasers and push rod tops, which are strain gauge. It's basically the top buckle of the suspension, the push rod. We strain gauge those. So you're allowed to run those in a race scenario just to get loads and damper pots. Those are kind of the main crucial ones. And then there's various temperature and pressure sensors throughout the car. So on each upright, you'll have a rotor temp, a caliper or a bearing temp, and then you'll have a wheel speed sensor. And then for race day, we also get a collector pressure sensor and a collector level for our fuel system. And so I can know how much fuel's in the car and when we're going to need to call the car into the pits.
And what about a testing scenario? What sort of other stuff? You mentioned pressure taps. Would you use anything like wheel force transducers or anything like that?
We haven't used wheel force transducers. Sorry, messed up my words there. But we haven't used those recently. We have in the past. But things like drive shaft torques, we're very big on the aero taps. I mean, that's a huge part of our game for Indy, is doing aero tap, pressure tap floors, pressure tap wings, and getting all the data from those. We run various, I mean, sometimes you'll go testing and you want ride height control. So you'll run some weight jackers or something that'll control the ride height as you go. We haven't got, other than that, we haven't done a whole lot of totally F1 spec, like a probe keel or anything like that. But that could be later on down the line.
I should just go back and just touch what I mean by wheel force transducer. It's essentially like a strain gauged wheel, which means you can measure the forces of moments from the tire. But I wonder if part of the reason you guys don't run those is it just a really tricky thing to build in 13 inches to take those sorts of forces? I'm not sure. Like, I know on larger wheels maybe it's a bit easier, but do you have any thoughts on that?
It could be very tricky, but it could also be a cost thing. So I don't know a whole lot about them in terms of the cost and everything, but I just know that we haven't really dived into those.
What about a slip angle sensor? You allowed to run those in the car? You do run them?
Yes, we do run those for testing, but not for race running. Also for, I should say, part of the race package is a pitot tube, which is fairly crucial for measurements. We do run those for testing as well, and that's where we base a lot of our reference off for the pressure taps.
So can you just dive into that pitot tube a little bit? I fly a plane occasionally, and we use pitot tubes for airspeed. Is that literally what you're getting from the pitot?
Yes, that is essentially what we're getting is airspeed, and then we have a lot of aero calculations that come off of that airspeed and that the ambient pressure as well, absolute pressure.
We've already talked, about a huge number of sensors really between even just with the race setup, regardless of the testing, the extra ones you'd run in testing. How much time are you spending going through and calibrating those sensors? Like, is it a thing where at the start of a race weekend you would go through and do like a bit of a data check, get everything calibrated right? Would you be redoing that every day or every session, or how does that look for you guys?
Typically, we do it essentially after every session or during the session if we feel like something's gone wrong. But it all starts, like for me, for this Mid-Ohio race that's coming up next weekend, that side of it will start on Monday, so which is tomorrow my time. So the car will be finished being built, and then as soon as it's being finished being built and completed together, I'll go through and we have a sensor checklist, and we'll go through and we'll calibrate all of the damper parts and we'll calibrate all the force sensors. Some of them are pre-calibrated. So like a pushrod top, we have a testing facility that we calibrate them all in a controlled environment. And so we have what's called a gain value, so pound per volt. And so we'll use that in our calculations rather than trying to calculate it on the car.
Can we just come back a little bit and talk maybe a bit more about the aero as well? You've already alluded to the fact that that's super critical, understandably, and particularly at somewhere like the ovals where the high speed is so crucial. Again, you've got a control chassis, so you mentioned briefly about the flexibility in the aero. Can you dig in a little bit, like what adjustments have you got, and how can you make that chassis different to the other teams running the same chassis?
Yeah, essentially, aero-wise, especially for the ovals, it's about how you build your wings, whether you have extensions on or if you have wickers on. You can do asymmetric wickers, so you can put them on one side, not the other. And getting also rake is a big part of it as well. And we've been utilizing the weight jacker for different elements of that as well, because it kind of raises or lowers the ride height in the rear. All
right, I'm just going to stop you because you just dumped in a bunch more terms that I think we might want to dig into for the aero dummies like myself. Wicker, what the hell's that?
Wicker. So it essentially for us, it's a little piece of carbon that you can bolt onto the trailing edge of a main plane or an extension. So it's basically a little 90-degree bit of carbon that you comes in various lengths, and you can choose. There's certain lengths that we're allowed, but you can choose one of those and put it in certain sections of the trailing edge of the main plane. Okay,
so I'm assuming there an ability to make subtle trims as opposed to bigger changes with the actual wing itself?
Yes, yeah. So those are more little changes. It does have quite a profound effect, but the big thing about the aero game, especially at Indy where your terminal velocity is so high, is just getting the balance right.
Sure.
And having the less drag down the straight, but also having the good balance in the corners.
All right. And the other term that I just wanted to dig into there that you've used a few times is weight jacking. So you've mentioned that that's a method of being able to control or adjust the ride height. So can you talk us through a little bit more about how that weight jacking actually works? And I assume you've got the ability to control that through the steering wheel, so the driver can control the balance of the car during a lap or during a stint?
Yes, absolutely. So it's driver controllable. It's a hydraulic system, and it's basically has the ability to increase or decrease the length of the right rear damper by about 1/2 inch. And so, which essentially transfers more or less weight to that cross, so the left front to the right rear, and does the opposite.
So basically, the ability to change the corner weighting
yes.
or cross weight on the fly.
Yes, exactly. Which is again crucial and changes throughout the stint at an oval at Indy. But when you do increase the length of that damper, it does raise the ride height a little bit, which of course will in turn change your aero balance and change the characteristic of the car, not only mechanically but also aero.
And would you be using that weight jacker on road courses as well, or is this purely an oval tool?
Purely an oval tool, so just allowed for ovals. Not that I would like to use it for road courses. I think that'd be great, but.
And maybe that's a good point, a good time to talk about sort of the difference in philosophy between a road course and an oval. Obviously, ovals are a pretty American-centric thing.
Yeah.
What's your approach to tuning a car or setting your car up for a road course versus an oval?
For a road course, obviously the major thing with the oval is the turning left. Much more crucial to get the aero balance correct for an oval. It's a lot more sensitive in that nature. For a road course, now I'd like to break the road course up because we have street courses and then road courses. Because we've just been to Road America, nice smooth track, low ride heights, high top speed, but you're able to tune the car completely differently to Detroit, for instance, which is very bumpy, high ride heights needed. You're hitting the rev limiter all the time, just simply based off the bumps. So it's just a completely different circuit. You got to run the car so much differently, sprung and different aero configuration.
Yeah, for sure.
With that ride height control or ride height change, how sensitive is the aero package on the car in terms of the downforce to that ride height?
Yeah, it's quite sensitive. A lot more so on the oval spec. The road course is less so, but the road course is more about mechanical balance.
Sure.
And not inducing too much drag. Now you get to some places like Road America has the fast corners, and so your air balance becomes a lot more sensitive, whether you're dealing with rake changes or if you're putting, using a wicker on a road course wing. Now I will say the aero configuration in general for a road course to an oval is very different. We actually use a completely different main front and rear main plane. It just completely different specification, and the oval being very, very simple, basically just one single main plane in the front and then one in the rear, whereas the road course is a triple in the rear and it's 3 in the front as well. But you have a little bit more options of what you want to do wicker-wise on a road course.
And as far as, could you give us sort of an order of magnitude, because obviously these single seaters are incredibly sensitive to small changes in things like ride height. If a driver came in and complained, let's say you're on a typical road course, a driver says, look, I've got a 5 out of 10 understeer, and you were going to do something with front ride height. What sort of orders of magnitude are we talking about here as making a ride height change?
We do it in flats. So you're like on your turnbuckle. So you would maybe take 2 flats out, for instance, or just like very small changes. You wouldn't really want to do it too much.
And when you say in terms of 2 flats, like at the wheel, what is that? That must be a fair bit less than a millimeter of ride height change.
Yeah, it's not a lot. I don't know the exact number off the top of my head, but it's not a lot of change.
Yeah, so incredibly sensitive, obviously.
Yes, incredibly sensitive. But when you start playing in that ball game, you get to the point where you're fine tuning and you're just doing a flat, or you're doing you get to that level where that window seems big now.
Sure. Do you use any simulation tools prior to going to an event to sort of build up a toolbox of, if the driver is complaining of this, well, this is the order of changes we're going to make and the magnitude of change will adjust? Or is that just something you inherently already understand about the car?
A lot of that is already understood. However, we do a lot of pre-event simulation. So there's a whole simulation package that comes out, but a lot of that dictates where you start the weekend. And so your start of weekend is usually not too far from where you're going to finish. And so from there, it's just fine tuning around that.
Mm-hmm. And what could you give us a little bit of a broad overview of what sort of simulation tools you're using? Is this, I assume this is like a full multi-body transient, like what I mean without wanting to throw too many crazy terms in there, like it's pretty complicated style of simulation, like pretty intensive.
Yes, yeah, very complicated. It is multi-body. It has a lot of your tire modeling and all these things, but they're all being developed. It's not really in-house by us, but it's some of our vendors that we use, and so they develop them and put them out there. And then we also do a lot of driver in the loop simulating. So basically correlating your simulated data to reality.
And how does that, what is the, we've talked about in terms of a simulation model for something the engineers are going to be using to understand how the car's performing. And then you've talked about driver in the loop, which is physically a driver driving a simulator. How does the link work between those two things? How does the simulation model that you're using for the engineers, does that essentially the same thing or the same model that the drivers are driving on a simulator, or is it two completely different things?
Well, they're very similar. Small changes, but essentially they're the same thing, so that you do correlate to real data. But the big thing with the driver in the loop is getting the tire model correct for a track or for a surface or for a car. Or if we're always, although we have alternate and primary tires, which are the red and black compound, the softer or the harder, they're always changing. The actual compound changes all the time. So it's about, finding that and then putting that through simulation, seeing what you think the tire model is going to be, and then going into the simulator, putting a driver in there, and then correlating that to reality.
With that tire model data, I mean, obviously that's a pretty critical part of getting everything else to work in the simulation. Is this something that the tire supplier gives you, or you actually have to take a tire and produce your own model?
Yeah, they give you a certain amount of data, but it's a little bit limited in terms of they just kind of send a blanket information out to all of the teams, starting with general information like the spring rate of the tire, the damping rate of the tire, the surface analysis of each track that we go to, especially somewhere like Detroit. We have multiple surfaces, concrete, asphalt, all of that. And then the engineers that we have will use that and put that into our simulation model and into the driver in the loop.
And I want to go back to what you were saying about getting the tire model right in the simulator, in the driver in the loop simulator. What's the order of operations here? This is about, you've got your sort of best guess at the tire model, you're putting that into the simulator, they're driving it and giving you feedback, say, look, I think this is wrong, we need to make this change, this bit needs to be different, and then you can go ahead and use that revised model in the engineer's simulation, or how does that loop look like?
Yes, we can do both of those. Oftentimes it depends on the scenario. If we've raced at a track before and we have the same compound, it's a lot easier because we kind of have that feedback from the driver already that, hey, the simulator tire model it didn't feel accurate based off what he actually felt in the car. And so we were able to adjust those parameters and adjust our tire model in the simulations and get better data. When you go to a new place, though, when you go to a new track, like we're looking at going to Nashville soon, which is a street course, and so that's a little bit of a guessing scenario. Other than we know that what the tire compound is closest to, so we know it's close to a St. Petersburg tire, for instance, and so we'll start with that and base it around that and kind of go forward from there.
And when you say that the compound is changing quite a lot, is this Firestone constantly, I mean, obviously they are evolving, but is this them constantly evolving a different compound, or is it more that there's a whole library of compounds that they'll take the one they think is best suited to this track, and it's pretty similar season after season?
It's more a library of compounds. So it'll be certain tires go to certain tracks just based off the loads that you're going to have at those tracks, or uh, obviously the oval tires are a completely different ball game. But just talking about road course, you have your hard and your soft compound tire. But if the hard compound is a lot faster than the soft compound, then the next year that we go back there, they're probably going to make the softer compound even softer, or figure out why it was slower to make it. Because the idea being that the soft compound is faster than the hard compound, but lasts for less time, or has a higher tire degradation.
With the sort of motorsport in general all around the world, we're sort of seeing a drive to try and bring costs down, and a big part of that has been reducing testing. So we've talked about simulation there. Do you use any other tools for improving the car without actually going to a racetrack? Do you use any wind tunnel testing or anything like that?
Yeah, so we do a lot of 7-post rig testing. I personally don't do a lot of that, but as a team we do, and we do wind tunnel. But the wind tunnel testing's also been restricted now, so it's a little bit less than we would like. And then of course, just on-track testing is also limited. But luckily, for instance, this year with Scott, we've got extra rookie days, so that's really helped out. But for the most part, you only get a handful of days a year.
Let's just come back a little bit to the aero stuff. So is that just to basically be able to throw, so to speak, the available parts onto the car and see what that actually does to the aero balance of the car, the downforce, the drag, etc. So you understand when you go to a racetrack from your options available what that's likely to do?
Yeah, that's exactly what it is. So we'll go there with a whole list of everything we want to try, and you'll step into the wind tunnel, and it's a very kind of rigorous procedure of just going down your checklist and checking each thing. So each time the car will run in the wind tunnel, you'll change one little thing, whether that be adding a wicker, changing the angle of the main plane, or changing the rake of the car or something like that. Luckily, the wind tunnel we use is rolling road, so we feel it's a little bit more realistic. But you're able to change your angle as you're going, so that eliminates some areas, or it makes the process a little bit faster.
This IndyCar chassis, we've already discussed how it's essentially quite restricted, the number of parts you can. There's lots of options, but this is quite mature as well, and it's been around for quite a long time. How is it that you need to keep going back into the wind tunnel to keep characterizing this stuff? Is it just that there's such a massive matrix of combinations, or is it because you're now running in a completely different ride height window than you were last time you went and did the testing? Or how is it that you end up having to go back to the wind tunnel all the time?
Basically, it's a combination of those 2 points you just touched on there, where you either find out a different window for your car to operate, or you're just exploring new avenues of the aero map. There's also sometimes every year or every so often they'll mandate a certain set of aero parts that you're now allowed to run, or you're allowed to run more of, or something like that, or you're allowed to run a different length, or so like a different length wicker, for instance, or you're able to go to a different main plane angle, and that kind of opens up that area of the aero map. And then so you want to go in there and test that and see what that does. But of course, it exponentially increases your options, because if you increase your front main plane angle, all of a sudden you want to test that, but you want to test that with a high rear ride height, a low rear ride height. You want to test that with a wicker or with a rear wicker, and a lot of different combinations.
For sure. I also use the term 7-post rig. So give us a bit of a rundown. That is something I'm familiar with the term. I kind of understand what it is, but I am actually interested to hear how that's utilized.
We do it for a lot of damper testing. So a lot of damper configuration. Obviously the 7-post in general is putting your car on this rig and running a track profile. So it just essentially runs it through the whole lap, or a whole race even. But we'll do a whole there's a lot of damper analysis and damper trials and trying different things, because that is one area of the IndyCar that is open, is damper development.
And I was just going to get Malcolm to explain exactly what a 7-post rig physically is for someone that hasn't seen one of those before.
So essentially, you put your car on a rig with load sensors beneath all the wheels, and it has pickup points throughout the car, and it'll control the car and do, I don't know if I'm explaining this in a really good way of visualizing it, but it'll control the car, pitch, ride, roll, as if it were on track on a lap. And then you can measure all of those loads going through the car and through the wheels.
So basically, you're looking to optimize that tire contact patch, and you can physically measure on a simulated lap how well that's working, and then make adjustments to your damper settings to try and optimize that further.
Yeah, exactly. Or put a completely different damper on, or change just basically changing the damper profile. But we can also do different things like anti-roll bars, front, rear thirds. So kind of tuning all of those together.
And is that something you guys own yourself, or you have to go out of your workshop to do that sort of testing?
We have it's out of our workshop, but it's within the team.
Yeah, right.
And I guess for those who maybe haven't seen one of those, they're also often referred to as a 7-post shaker, which is kind of what it looks like it's doing to the car.
Yep. Yeah, when you run a track profile of Detroit, it's kind of scary to watch.
Do you have to have some straps on that thing to stop it jumping around, or what?
Yeah. We've broken some stuff.
Better to break it there than on an actual racetrack, I suppose.
That's true. Absolutely.
Can we just talk a little bit about Scott? So again, I mentioned that he's come from supercars, which is basically a tube chassis sedan with a 650 horsepower V8, and they're sort of referred to here in New Zealand and Australia as taxi racing, because that's kind of what they started out from. Obviously a big shift, taking someone who was at the top of their game in V8 supercars and then putting them into an open wheel wings and slicks race car. What have the challenges been for you working with Scott to get him to adapt to the IndyCar?
He's incredibly talented. So it's definitely has not been as difficult as I originally kind of thought the transition would be, because it's a completely different animal. And I know from his history, he's been a big tin top racer for quite a long time. But he's adapted incredibly well. But I don't, obviously the simulator testing helps a lot, and being able to have the odd rookie test day definitely helps. But the transition has been pretty good. I think the hardest bit is when we go to tracks that we don't get to run on a simulator and that are very bumpy.
How much, I guess, has he been leaning on you as the data engineer to try and help him find speed out of the car?
We do a lot of driver analysis, I suppose, more so than with the other
Sure.
guys. So just overlaying basic driver input, so throttle, brake, steering, with the other guys. We also look at oversteer and understeer metrics to see how the car's behaving, if he's inducing something that he shouldn't in the car, or whether he can utilize it, you actually use the car a little bit more. One of the big points that we've been working on recently has been the transition between the black tire to the red tire, and being able to fully use everything that the red tire has to offer. And so that's one thing that the other guys just inherently know.
Sure, yeah.
But he's been learning.
And what's, coming back to a little bit your role inside the team, what's the sort of technical structure of an IndyCar team, of your IndyCar team and maybe some other IndyCar teams up and down the pit lane? Does it vary much? Like, how many engineers have you got per car, blah, blah, blah?
It does vary a little bit. Our team, we run maybe a little bit slimmer than some of the others in terms of what's on the timing stand. We run basically have a strategist, a race engineer, a data engineer, and a performance engineer. And then there's also an engine engineer that comes from Chevrolet or Honda. And so that's how we run. Some of the other teams run more of a like a race engineer and an assistant race engineer, and then they have a data engineer. But the roles are a little bit different. Whereas our role, my data engineer role, is kind of almost like a control systems / partial performance engineer / data engineer. Whereas some of the other teams run more of a structure of having the assistant race engineer do all of that, and the data engineer is a little bit more of a lower, kind of not as responsible for the direct running of the car or the running fuel or anything like that.
And could you sort of talk through some of your responsibilities, sort of going through a bit of a week in the life of Malcolm Finch, sort of pre-event, during the event, post-event? What does that look like for you?
Of course. So pre-event, like starting this week, pre-mid-Ohio, we'll be doing sensor checks, sensor calibrations. I do a lot of pre-event strategy stuff. So sorting out your pit stop windows and knowing some of the historical facts, like how many yellow flag caution periods are there, when do you pit, like if a caution comes out lap 10, for instance, do you pit or not? And then, so we'll do a lot of that race strategy prep. And then going into the weekend, we usually have a bit of a setup morning. So for instance, this week will be a Friday setup morning, and then we do our first practice session in the afternoon. But by that stage, by the time you get there, the car's pretty much already ready to go, and you're done with all of your pre-event stuff. But then as soon as the car runs, and after that, you can start analyzing your pre-race strategy packet, and then going through that and adding in relevant data, checking if the track pace has changed drastically, or last year we got the addition of the windshield, which changed the lap speed of the car by quite a lot. And then we, of course, do sensor checks after every session. And then going through the rest of the weekend, it's basically the same for the Saturday, but included with a qualifying session. And then come race day, it's definitely my favorite day of the weekend. Wake up early, go to the track, have breakfast, do your final sensor check and everything. And then during the race, the data engineers for Penske, we run race fuel. So just always looking at pit stop windows, when you're going to pit, a lot of strategy oriented options. And then hopefully you come away with a win, a trophy, and a checkered flag.
And on that, I just want to dig into that question about fuel, which is obviously a pretty massive thing as far as strategy, particularly in America, where you're sort of running those yellow flag gambles a lot. What does that mean for fuel calculation? If you could just talk through what a fuel calculation means and how that works.
Yeah, so basically they try and do every race to where there's 2 or 3 pit stops. And so you'll run your car until you can run out of fuel, or you'll pit to where you can do it on 2 more stops at some sort of nominal gallon per lap number. So you're constantly analyzing fuel economy. So you're always thinking about how far you can go and relating that to strategy of where you're at on the track, and whether you can do an undercut, or whether you can do an overcut, whether you want to be trapped out and a yellow flag comes out and then you can enter pit lane or something like that. But that's a very large part of my race day job, is running fuel and analyzing that as we're going.
Have you got a dedicated software that's doing that sort of analysis on the fly during the race for you, or is this stuff that you're actually physically calculating?
It's a combination of things. I run a Excel fuel sheet that's linked to telemetry, so it gets all of the telemetry values from the car, and it automatically updates lap on lap of how much fuel's in the car, where we're at, and what our average fuel economy has been over the last few laps. And you can do type in predictive strategies. So if I'm going to put in 5 laps, what is my next pit stop window is going to look like? You can also, what I like to do a lot of is predicting the other people's strategy. So you if they're pitting, you can see, okay, well, they're going to need this gallon per lap to make it to the end, or something like that. and what their relative pace could be. But in terms of a strategy software, we do have a strategy software with all of the timing data that comes from the track feed. So we utilize that quite a lot. But essentially, the fuel and the strategy are two separate but combined things.
Is your strategy sort of also driven a little bit by other competitors that you're on track close to? You know, do you have to sort of respond to someone who's pitted to prevent the potential for an undercut if you stay out?
Yes, absolutely. Pre-weekend, we work out whether it's going to be an undercut or an overcut scenario. But during the race, you kind of have that in the back of your head, but you're always analyzing what the other guys are doing and whether they're in traffic. Traffic's a major part of it. Whether you're going to come out into traffic. So you're always looking at what your time loss is in the pits and where you're going to come out on track once you do pit. And then making sure that you capitalize on all of that and you're able to have a good in and an out lap and really minimize your pit loss. There's the nice thing about IndyCar is with the refueling and everything, there is quite a lot of option for split strategy and your ability and the yellow flag scenario where they close the pits. So it opens up a lot of potential to do something tricky if you're down the back of the field or to get caught out and have a really bad rest of your day. But it's very interesting analyzing that on the fly and watching these guys. But we have the software tool that we use I'd say it's not too complicated, but it takes a lot to get used to. But we use a lot of graphs, you're always analyzing the pace and the gap to the other people. But you're also looking at what tire they're on and whether their pace drop off is due to the track evolving or whether it's due to their tires falling off or if it's just inherent within their team or something like that.
Sure.
And you mentioned as well, you've got a dedicated strategist on the timing stand there for each car. Sounds like you're all over the numbers side of all of that. How do they play into that role of strategy? Is this essentially some old guy with a cigar just making the calls, just vibing it, or what is this?
No, they usually play an integral part, but it's less on the number side and more on just analyzing what's going on, basically coordinating, making sure we're all on the same page, and making sure we're not overlooking various aspects. But it's kind of in terms of strategy, it's a combination of data engineer, race engineer, and strategist who are all conversing during the course of a race. And you're always talking about various things about undercutting into free air or do we short fill on a certain stop. So to fill an IndyCar, it takes between 4.5 to 6 seconds for 18 gallons. So it's relatively quick fill, but sometimes you want to short fill it to beat someone out of the pits, or you're wanting to just find any way of getting an advantage.
So that role of the strategist is really to have a good overall sort of look at the entire race situation and just be looking from a bigger picture rather than be too buried in the numbers.
Yeah, essentially. They also do all the communication with the car.
Okay.
So it's so they are the main point of contact on the radio. So it's a big communication aspect as well. Some of the other teams run their system a little bit differently, where the strategist isn't the main point of communication, but that's how we run it. It's been pretty effective. But yeah, so like you said, basically an overall view of the entire race, everything that's going on, making sure that myself as a data engineer or the race engineer doesn't get too sucked into any one strategy or any option and miss something that just globally would have been better for us.
You also mentioned that you've got an engineer from Chevrolet that's there in charge of looking after the engine, and we've got two control engines in the series, Honda and Chevy. What's this guy sort of in charge of? Is it just a reliability aspect, making sure that everything's going to hold together for the length of a race, or are there actually adjustments that the person is making to the calibration to suit?
There are some adjustments. They're a little bit limited in what they can do, but they do a lot of driver control aspects, adding certain things to help a driver, whether it's on his throttle control or how the engine does certain things, or how it goes into the rev limiter, goes into the soft limiter.
Sure.
So there's a few things he can change, but a lot of it is just performance based, making sure that the engine is always performing at its peak.
So more around there is some actual potential, despite it's a control engine, there is some potential to adjust or map the drivability of the engine to suit the preferences, of a specific driver.
Yes, absolutely. And then of course the driver can, if we have different options set up on the steering wheel on his map positions, he can cycle through those throughout the course of a race. So if we're going to, if when the tires get old, we might go to a different map setting, which will give him a different drivability function off of the corner. And so he's just able to, it's, a little bit softer, doesn't build quite as much boost or something, and just helps him get away without wheel spinning. So there are some areas for adjustment for the engine engineer from that standpoint.
On that note as well, you talked obviously just previously about fuel strategy and fuel burn. So is that another adjustment if you've wanting to run the drive a little bit long and maybe the fuel burn starting to get a bit marginal? Can you go to a different map that's going to be a little bit more economical? Maybe you're sacrificing a little bit of power though.
Yep. Yeah, we actually, throughout a race, there's 4 or 5 options that we can usually change to. We start with race rich, and then we can go to a mid lean or a lean map. And that reduces the gallon per lap by quite a lot. But obviously it slows you down by quite a lot too. So you'll you're in certain scenarios where you just have to analyze that pace drop off and whether it's actually worth it.
Sure.
In terms of the middle of the race. But if you're at the end of the race, you're just trying to make it to the end, you're kind of stuck with whatever you have locked in there.
And as far as there's obviously a pace difference with that different map, is there a potential reliability risk as well with running it leaner, or is that not so much of a problem for you guys?
It hasn't been so much of a problem. Definitely not running it lean. Sometimes the accuracy of the fuel number that you're receiving changes a little bit. So when we're running fuel, we have this thing called fuel error, and we'll calculate that as we go as to basically the readout that you're getting and what's actually being burned on the car. So you're just kind of analyzing that as you go. But in terms of a reliability standpoint, I haven't seen there's nothing negative from going to doing a lean map.
And when you're comparing it to the actual fuel burn, this is as far as measuring how much fuel you've put in at each stop by measuring the weight of the fuel rig before and after?
We don't do it by weight, but we do it by volume currently. Like before pre-session and post-session, we'll pump in a certain amount of fuel and then we'll pump it out. And then during the session, when we want to fill up during practice, we'll actually fill up with a digital readout. And so we'll get a measured amount that goes in each time. And then we calculate our fuel error based off that. And then during the race, you just kind of know what your capacity is. So you kind of have to estimate that that's what it is. There's a sight tube on the fuel tank, and you're able to read that, but it's not as accurate as if you were to get an actual milliliter value.
I wanted to come back and tie off when we're talking through sort of the week in the life of a data engineer for you. What about the post-event? How does that look for you, Malcolm?
Post-event, we do a lot of data reductions on all of the sensors, making sure all of the sensors are working properly. Essentially, that you start with a reliability standpoint of each sensor, and then go through into the performance side of what did the loads look like, what did your damper pots look like, and everything like that in terms of wheel travel. And then I'll look back at the strategy over a weekend. We'll do some reductions on that, do some little bit more graphs and some visuals in Power BI, and see how the different strategies played out over the race, and what worked, what didn't work, what might we do different, and kind of put together a bit of a summary as to, so when we go back next year, we have a clearer understanding of different how the race played out. And then for the most part, by the time you finish with that, you're starting to get ready for the next race. So kind of all starts back over again.
Just in terms of when you've gone to a particular event, and obviously you've started with a particular setup at the beginning, and you've probably evolved that, no doubt, over the course of practice and the race itself. And then you've talked already about the simulation tools that you use before you get to an event. So next season, when you come back around to that same event, how are you sort of weighing up like what value you put on your setup from last year that you've got, you know what it did, versus does that just become the starting point for your simulation before you go to that same event? How does that work out?
Essentially, yes. It's highly dependent on which track, though. When you go to like Indy road course, which is the track doesn't change a lot. It's pretty similar. We usually run the same tires there. You'll start where you left off. But if you go to like Detroit, for instance, you might rerun your simulations and see what might be beneficial for, like, do your best estimate as to how the track may have evolved. Like it spent several months underwater, so you're kind of guessing that some of the track is probably going to be a little bit green, and the surface may have changed quite a lot, right?
Yeah.
But for somewhere like Road America, a little bit more consistent, same tire compound, you'll just kind of start where you left off and have some options in your bank. So when you do the drive in the loop, maybe we go with a different damper package because it would have been better for a race scenario. So you try what you would have tried at the race in the DIL and then gone through those options and narrowed it down to some that you want to try when we get to the track.
And on that as well, when you're rolling out at in practice one, after you've done all of this pre-event work, are your drivers close enough in terms of driving style or just the way they approach driving the car to be able to split the setups a lot and be able to learn a lot? Or is it just there's enough differences in the way some of the drivers drive the car that you can't necessarily chuck 4 different setups at the car and to try and find some directions?
I think it depends on where you are, but they are a little bit different sometimes in their driving style. They all do slightly unique, but some of the, like definitely for a street course scenario, that they all tend to drive it a little bit differently. But we've just been at Road America and they were all relatively similar there. So that would be a track that you could go to and you could try a couple of setups on 2 different cars and get the feedback from them and say, yeah, we really like that damper set. Let's try those for next practice.
Yeah. And you find, how does that flow of information between the team? Obviously, you guys are a team. You're also competing against each other. Is it essentially an open book? You guys are all debriefing together. You guys are all sharing all of this stuff, or is there can be a little bit of cat and mouse with this as well?
No, we all debrief together, and we share all the information. It's all there. All the comments and the feedback and everything we store in a big database. So you can go and you can look at what Joseph said about a certain, like for that run, they put on this other set of, they went softer rear springs or something. So you can look at what his feedback was. But all the drivers can talk together and think about different options and talk about driving style or talk about whatever. It's pretty open within our team. But then come race day, then it's a competition. Then it's a little bit.
And would you guys be listening? You guys are scanning each other. You can directly hear what's happening on the other timing stand, or is it pretty much in a silo for the other teams?
We can't hear the intercom, but we can scan the other cars. So that's another aspect of race day for everyone that's on the timing stand is just scanning the other radio frequencies, because you have everyone's radio frequency. So you can scan any car in the field and listen to them. But sometimes, yes, you end up just listening to your team cars.
Look, Malcolm, really appreciate the chat. It's been great, but we do want to be respectful of your time. So I think we'll probably wrap it up here. Is there anything that we haven't touched on so far during this chat that you think is really critical that we've overlooked? Anything really important that you'd like to talk about?
No, I think we've covered a lot. We have covered a lot. I'll probably end this conversation. I'll think of 5 more things that I want to tell you guys, but I think we covered definitely the gist of IndyCar in general and the total role of being a data engineer pretty well.
And so what's up next for you? Are you pretty happy where you are? You think you're going to be moving up through the team into different roles? You think you'll be sticking around in IndyCar for a while?
I'd like to try my hand in the performance engineering field, which we have a few of those guys. We're also starting the Porsche program this year, so that's going to open some avenue for expansion for some of the team to go do some endurance racing. So we'll just kind of see how the rest of the year plays out. But Penske's really good to work for, so I can't complain too much.
If you sort of had your time again, maybe for those watching or listening to this who are interested in maybe pursuing a career in engineering at the level you're at, is there any advice you could give them?
Well, there's definitely lots of advice, but definitely getting as much experience as possible. If you're starting off really basic, to volunteer for race teams, doing whether it's Formula Ford or just learning as much as possible, basically. What I found was really cool when I was volunteering is you could go learn about these theoretical things and then go and apply them to a real life car and in a less stressful environment. So it's very fun doing that. And then one thing leads to another, and then all of a sudden you're on a big race team and you're expected to do that for a living.
Could be worse.
Yeah.
Well, I haven't got anything else, Andre. Do you want to wrap it up here?
That's been great.
Yeah, really interesting, Malcolm. Thanks so much for your time. Cool. Thank you.
Cheers.
Yeah, I appreciate it, guys. Thanks for having me.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.